Hi, so here's a demo of the AI assignment one. So first I'm gonna run each of the solvers one by one. So I can specify which solver I want in the command line here. So I'll start with depth first search. So we can see here the start and the end goal are shown in blue and green. We can see it's a pretty inefficient path. Um, and so we'll do BFS. So we can see this is actually an optimal path for the grid that we've been given. Obviously, it's not completely a straight line, but due to the maze. And then we'll do the A star using the Manhattan heuristic. So also optimal. So obviously these are all for different grids at the moment because I'm running it individually. But we'll see later that I can run them all at the same time on the same grid. Another solver, and then we'll run the MDP solutions. So value iteration. Here we go. And also policy iteration. So that's good. It's kind of hard for us to compare though. So what I can do is I can run them all at the same time. So not all at the same time, but all on the same maze. So here we can see depth first search. And we can see it's kind of hard to tell if this is, oh yeah, so we can tell that this is suboptimal because even so when we're here, we could just as easily go like this, and that would be much quicker. Okay, also we'll see this is actually the optimal path. So now this is BFS, which we can see at the bottom. Then Manhattan, Euclidean, value iteration, and now policy iteration. So that'll take a bit longer. But it's kind of hard for us to extract information about this or metrics. So I have another script for this, benchmark. So here I can set like what sizes I want to benchmark on and the discount values and threshold values that I want to iterate through for the value and policy iteration. And everything gets saved here to a CSV or a JSON. But let's keep going with the main solvers. And we can specify other features, so we can specify the width and height. So if we want to do 100 and 100, so we can do it like so. It might take a little bit of time. There we go. So we can see depth first search definitely took a while there, and this doesn't look particularly efficient. I mean, maybe this maze is, but we'll see how BFS does. So yeah, much quicker. Same with Manhattan and Euclidean. So value iteration, policy iteration will take a while here because they have to, obviously, they operate over the whole grid. So they'll take a bit longer than some of the other solutions. There we go, there's value iteration. And now policy iteration. This might take a little while. But so while that's solving, I'd encourage you to look at the benchmarking for yourself. So the benchmark.py file. So this is generates the main metrics and information that's then used by the graphs.py file to create the graphs used in my report. So this tracks a lot of things. It tracks time to solve across lots of trials. It tracks the memory used. It tracks the impact of discount and thresholding on if the policy actually the optimal policy actually reaches the end or not with value iteration and policy iteration. Yeah, it creates metrics for a lot of very interesting things. So there we go, policy iteration. So as you can imagine, value iteration and policy iteration are sort of two of the slowest when I compare them in the report. But so that's kind of a brief overlook of what I've done. Thank you.